Okay, Assalamualaikum. Alright, how's everyone? Semua harapnya semua okay ya. So today is a new chapter for you. So previously kita belajar on beam analysis. You are looking at the behavior of beams due to shear force diagram and bending moment diagram. Okay, so from there, right, we can see what kind of behavior that the beam will experience in future, meaning that once we do the analysis, we could expect what kind of I should say deformation or faulty that might happen to your beams through the analysis. Okay, today's lecture is about influence line in beams. Okay, so just now I already share with you a video in Taiwan, a bridge collapse. Doesn't affect anything, meaning that there's no external loading that affected to the beams. Okay, if you see the videos that I've shared with you, there's no any excitation loading that comes from an earthquake. There's no any wind loading that comes from the excessive winds loading onto the bridge. Okay, it's solely on the failure of the beams. Okay, beams of the bridges. Okay, so the bridge component consists of truss and also beams. Okay, so you can see the collapses of the bridge due to the what? So later I will share with you why it collapsed. Okay, so it does influence. Okay, it does influence the behavior of the beams that we analyzed before. Okay, so through the analysis of beam in finding the bending moment diagram or shear force diagram, it doesn't show any like particular I should say indicators telling us that the beam will fall or the bridge will be collapsed. Okay, so we have to extend another analysis that we call it as an influence analysis in beams. Then here we can see extra ideas on how the beams will behave due to the forces that comes from the external loading and also that comes from the reactions or even a movement of a moving load. Okay, and we can see due to these forces, how does it affect to the beams, especially to your beam structures, especially on your columns, on your connections. So how does it will react? Okay, right? The idea of today is we want to see, right, the influence diagram. How are we going to draw an influence diagram in a determinate beam? Okay, determinate beam, contoh determinate beam macam mana? I have a pin and a roller at the end. Okay, I have a fixed beam there, a fixed beam, and then I have an overhanging beam, right? So this kind of beam is called determinate beams, subjected to a moving concentrated load, uniformly distributed load, and a variable load. What does it mean by moving concentrated load? Moving concentrated load means, it means, right, I have a moving load here. Okay, I have a moving load here, right? And it moves from this point to the other point. So during the moving loads, okay, we analyze the beam behavior, right? Contohnya macam tadilah, we have a car or a lorry just now, a truck just now. Okay, there's a truck just now here at this point. This is a truck. And the truck is moving from this end to the other end. Okay, what happened to your beams? I want to see the influence of the beam. So just now we can see that the beam is broken down into two pieces, meaning that it collapses. I don't know why it collapsed, and later we will see how it collapsed due to these moving vehicles. Okay, moving concentrated load. How about UDL? UDL, maybe there's a machine there, right? So there is a machine there. How does it behave to your beam? Okay, is there a machine, right? How does it behave to your beams? And then you have a variable slope, meaning that I have a point load here, I have a knife load here. So how does it behave your beams behavior? That is meant by subjected to a loading. So we want to draw this influence line. So we want to draw this line actually. How we want to draw this line? How are we going to draw this line? Okay, that's a principle of drawing this line. And the second one is to determine the location of moving loads that produce the maximum support reaction, shears and moment at specific points. And here we want to determine what is the maximum, okay, bending moment, maximum shear force, okay, what is the maximum reactions, okay, support reactions, meaning that reactions at, okay, at X direction, reaction at Y direction, or it has a moment react at that particular point. So we want to see what is the value that occurs at these lines. Okay, right. All right, here it shows that the progressions of the collapse from picture 1, 2, 3, 4, 5, and 6. Okay, we already see this progression of the collapse, right? From the videos that are posted at the Facebook just now. Okay, so you can see here, what I want to highlight here is the beam. Where is the beam? These are the beams. Okay, these are the beams. Beams of the bridge. Beams of the bridge. Okay, so this is happen when the beam of the bridge is at stable state. What happened is it is not in a stable state. What happened? So you can see the curvy line of the beam bridge. Okay, and it started to collapse, broken into two pieces, several pieces actually. The first one, second one, third one, and the fourth one. Okay, I want to show to you. It broken into a pieces. Okay, 1, 2, 3, and 4 pieces from one nice beam. Okay, so what happened? These 4 broken down pieces, so it start to collapse, falls onto the river. Okay, it started crashes down here. Okay, onto the river. So you can see here at the end of the beam here. Okay, this is at the end of the beam here, meaning that you can see at the beam here. Okay, at the end here. So it highlighted that this is your truss and this is your beam end here, and this is the beam that collapsed from this point. Okay. Okay. So we as engineer, we have to analyze the beams based on several parameters. What are the parameters that we have to find? The first parameter, we want to find the maximum reaction. Number 1 is reactions. Okay, so I've explained to you just now. Okay, RAX, RAY, and moment. Number 2, we want to see the maximum bending moment. Where is the bending moment maximum occurs? In this collapse due to the forces. Okay. Number 3, we want to see the maximum shear force. Okay, shear force occur in the beams. Okay, in the beams. So we can see here, Okay, if let's say I'm highlighting the where is the vehicle. Okay, where is the lorry? The lorry is here. Okay, it starts moving here and it tries to climb the bridge as soon as possible. It's here. Okay, the lorry is here and the lorry is already climbed at the end of the beam here. Okay, beam that connects to the column pier bridge there. And it starts to fall down. Okay, unfortunately the lorry cannot be saved. It falls down into the river. Okay, so I want to say that here, I want to highlight that here is this lorry is moved from this point to the other end. Okay, so the lorry is here now. It's here now. Okay, earlier on it's here, now it's here, and then it moved to the other end here, and it starts to climb towards the end until to this point. You can see the progression of the moving vehicle, which is the lorry. Okay, you can see the lorry is moving from one end to the other end. Okay, the idea I want to highlight here is while the lorry is moved from this end to the other end, okay, meaning that, right, it will create a vibration. Okay, it will create a vibrations in the beam. Okay, it will create a vibrations in the beam. So the progression of the vibration in the beam, let's say I draw my beam here. Okay, let's say I draw my beam here at the top view. Okay, this is the top view. Okay, and this is my lorry. Okay, my lorry is moving from this end to the other end. Okay, what happened? The lorry, okay, creates vibration. It creates vibration. Okay, it creates vibration. Okay, the vibrations will transmit to the beams. The vibration will transmit to the beam. Okay, will transmit to the beam. Okay, transmit to the beam. Okay, transmit to the beam. Okay. What happened in this case, once the vibrations transmit to the beam, meaning that your beam, okay, your beam at end here, okay, your beam at the end here cannot resist the vibration. Cannot resist the vibration. Once it cannot resist the vibration, not only the beam, it also the truss of the beam. So this is the truss. Okay, you can see the truss. You can see the truss here also cannot resist the vibration that comes from the lorry. What happened? You can see the rope. Okay, or you can see the cable. The cable in the truss. Okay, you can see the cable in the truss. Okay, you have a straight cable here, perasan tak? Okay, and suddenly the cable is putus. Broken into pieces. You can see see? Alright? Okay, you can see here. Nampak tak? It snap through. Meaning that it snaps through. Okay? So meaning that the beam cannot hold the vibration and the truss also, okay, the truss arch truss also cannot hold the vibration forces. So it snapped through the cable, cannot hold the cable, then the truss cannot hold the cable, and the cable snapped through and the bridge falls down. Plus, besides that, the span, you can see here, the span of the bridge. Okay, you can see here. Let's say I draw the span of the bridge. Okay, the span of the bridge, it's quite long. Okay, it's quite long. So it don't have enough support in between. Okay, kenapa tak enough support in between lah? Okay, because the vibration cannot afford to sustain by the beams. Maybe at this time you have a wind loading. Okay, we don't know. Okay, so here, why they don't want to have this pillar? They want to have the lorry. Okay, the boat here to crosses along the river. Dia nak cross along the river, so dia tak nak any interference of column in between. Okay, that's the idea. Okay, however, unfortunately, okay, this event caused the bridge to collapse. So, kesian lah, right? So, we as engineer, we have to find, right? Or we have to design. The idea is to design. Okay. What is the best design? You want to have this kind of span. Okay, span of the bridge, right? A longer span. You don't want to have an interference of the column in between along the river. Okay, and you want to have a strong column. Okay, you want to have a strong column, strong beam connection. Okay, want to have a strong beam connection, strong cables that can tie the beam beneath from the arch truss. Meaning that the main component here is your truss, your cable, and also your beam. So when you want to design, so you have to consider these three components into your design. So in design, it's about how to design a safe component, right? But in the analysis, okay, we want to check, okay, to check what? The bending moment, the shear force, and the deflections behavior of the bridge. Okay, there are two different things. So here I'm highlighting the analysis part and also the design part. The design part is you want to design a safe design, and the analysis part you want to check. Okay, it's actually you want to check. You want to check the condition of your bridge. Okay, you want to check the condition of the bridge based on beam analysis, shear force analysis, and deflection analysis. So later on in our future classes, we will see how are we going to check this beam bending moment, shear force, and deflection analysis in influence line analysis. Okay, right? So the purpose is, so just now already mentioned to you, so the purpose is to check, okay, is to check the behavior of the beam based on the bending moment, shear force, and deflection. Okay, right, via analysis. What analysis? Your influence line analysis. Okay, that's the idea. Okay, right. So, what functions, which function you want to check? Bending moment, shear force, and also deflection. Okay, which location? Okay, at the connection. Okay, connection of what? Beam and column or pier just now. Just now kita ada pier, right? Beam column joint, alright. or in the beam, in the beams, okay, at the end, okay, sorry, at the end of beams, in the middle, sorry, middle, okay, or along the beam. Okay, so that is the idea, in the middle, along the beam, at the end of the beam. Okay, kat mana you nak cari? So you can determine the location of these three functions using the influence line analysis. So to see this, okay, to see this analysis output, okay, output of bending moment, shear force, and deflection. So we have to draw. We call it as a influence line. Okay, influence line due to what? Due to this function of bending moment, function of shear force, and the third one is function of deflection. Okay, that's the idea. Alright, so saya harap sampai sini you guys faham lah. Kalau tak faham, please put in the comment box. Okay, for example, so these are the example, right, in our analysis, the output of analysis using a software tools, using a software tools. Software tools can be any type of software tools, kita ada Bentley, okay, nama software ni panggil Bentley. Bentley ni untuk design bridge. Dia famous in bridges. Okay, bridge analysis. Okay, Bentley ada SAP. Okay, SAP 2000. Okay, you have this other one is Abacus. Okay, kalau Abacus lagi specific lah. At the very every each connection you want to see the influence line. Okay, so macam ni nampak tak these bridges? Okay, this arch bridge. So you can see a cable here, okay, and then you ada arch bridge and a beam, okay, and this arch bridge is being supported, okay, being supported or fixed at the end of the earth. Maybe dia ni dekat tepi-tepi bukit, alright. So you can see the connection here. Nampak tak? Nah, ni nampak tak color of forces? So merah tu lagi tinggi lah, higher force, and this is the lowest force. So you can see here the force is higher at the connection between the force at the end of the arch, okay, truss, to the earth, okay, earth, bukit. Mungkin kat sini ada bukit, right? Kat sini ada bukit, right? You can see this is the highest point. So you can see here ada point dekat sini. And then through the analysis, these are called the influence line. Okay, these are the influence line at fixed end. Here, dekat hujung ni, fixed end. Ni fixed end. Ni nama dia, fixed end. Fixed end of load condition. Dia nak based on apa? Tadi kita tengok tadi ada bending moment. Okay, ada shear force ataupun deflection. Dekat sini dia hanya fokus dekat mana? Dia hanya fokus dekat bending moment. So bending moment and also axial force. Okay, so axial force. Okay, so this one, okay, this one is the bending moment, and this one is the axial force. Masuk axial force dengan bending moment tu yang mana? Okay, so yang ni. Yang ni bending moment dia. Ni bending moment. Okay, moment dia berapa? Yang mana maksimum? So kat sini yang paling maksimum. Kat sini paling maksimum. Okay. So yang ni color apa? Color hijau. Bila color hijau okey tak? Okey. Kalau okey boleh proceed to design stage. Macam tu je. Okay. Design stage. Boleh proceed terus design stage. Tengok whether dia safe ke tak. Okay. So here you tahu tak safe ataupun tidak. You tak tahu dia safe ataupun tidak safe. Okay. You tak tahu. So you kena check lah. Okay. So yang ni it's axial force diagram. So, axial force. Dia dalam bentuk apa ni? Color apa ni? Warna merah. Warna merah. So, merah okey ke tak okey? Oh, merah mungkin tak okey. It's not okay. So, boleh tak proceed dengan design stage? So, tak boleh. Okay, tak boleh lagi proceed dengan design stage. So, you have to reanalyze balik. So, you need to reanalyze back. Okay, analyze back until dia okay. Until dia ada permissible values. Okay, ini kena check dengan design book. Okay, so here pun ada juga bending moment at the upper and the lower. Yang tadi ni upper, lower. Maybe dia looking at the, ni nampak tak ada value kat sini. Ni maximum, minimum. That's the idea of doing the influence line analysis. Okay, right? Okay, this ada satu contoh paper. Paper, it's a journal paper. It's a seismic response analysis. Okay, based on the arch bridge. Okay, kalau tengok dekat sini, they want to find apa? Okay. Alright, dia nak cari function using finite element software. Saya panggil MIDAS. Okay, this is the MIDAS software tools. Okay, dia nak kena model. Dia nak cari internal and displacement response. Okay, so based on this, dia nak cari internal and displacement response. Internal force. Okay, force. And also displacement. Nak cari dua. So, bila dia buat analisis, dia boleh tengok dekat mana, how does it respond towards these forces and deflections. Okay. Macam mana output results lah. Output result nampak tak macam ni? This is the output. Ini contoh lah. Output results. Okay. Output result for longitudinal displacement, lateral, vertical displacement. Okay. Berapa sentimeter. Okay. At this location. At this location. Nampak tak ni location? Can get the idea? Alright. So, these are the function. So, this is also the function. Okay. And these are the results. You can see these are the results. These are the results. Okay. The result, the values based on the function internal forces and also the function of displacement. So, from the analysis, dia kata dia ada summary, nampak? Dia kata maximum vertical displacement occurs at the arc foot and the value